Statistical process control summary. Statistical process control has these four parts that are done in a kind of cycle. So one of those parts is capability analysis. This is where, if you recall, we calculate capability ratio or capability index, and we try to see if the process that is hopefully in control is producing something that is sufficiently good for the desired quality, right? Capability, a process is capable if it is producing products of good quality almost all the time or all the time. And of course, if you recall, for that we used capability ratio or index, and we said it is capable if those numbers are at least 1, or Six Sigma capable if these numbers are at least 2. The other step, and then the next step in the cycle, is conformance analysis. This is where we set up control charts, either for variable X bar and R chart, or for attributes. We gave an example of the P chart. And these charts, we use them to see if the process is in control, meaning that it behaves similarly, right? It has similar variability as it had in the past. And of course, the advantage of those, right, the conformance analysis, the charts give us the advantage that they alert us when control has been likely lost and there are some assignable cause variations happening in the process, right? That's conformance analysis. So the third step here is when we detect that there is some variability that is unusual, right, and there might be assignable cause variation, we investigate for those assignable causes. So this is the third step here, right? And we try to find root cause or causes, right? Something that caused that unusual variation, maybe some kind of problem in production or in delivering the service. We try to detect whether it is due to people or some equipment malfunctioning or something else, right? And then the fourth step is eliminating that assignable cause. So basically applying some kind of corrective action, whether it is in the service process or in the manufacturing. And of course, these steps should be done in a cycle. Hopefully, we improve the quality through this. And when the quality is sufficiently good, we make sure it doesn't deteriorate without us noticing. When do we use variable control charts, and when should we use attribute control charts? Well, sometimes we have a choice. Maybe there are several variables we can identify that determine quality of the product or quality of our service. And in that case, we might want to control all those variables, or we might create maybe one P chart to detect if the end product was defective or not. But if there is just a single measurable variable that determines whether the unit is defective, it's always a good idea to choose X bar and R chart, right, together. Remember, they come always together to control quality because they carry additional information that is discarded when you use the P chart, right? Here we see, for example, the average measurement, and we can see how it compares to specification limit, which are not shown on this chart. Remember, it only shows control limits, right? So there is an advantage of using variable control charts when when there is only one variable or maybe very few variables to that determine the quality, whether the service or product was of sufficiently good quality or not. But when there are many variables or many potential causes for defects, and sometimes maybe even hard to identify ahead of time, right? Variable control charts may be difficult or even impossible to implement. And in this case, it's a good idea to use P charts, right? Examples would be errors in order entry for some products, when we have sales, or lost baggage for an airline, or wrong medication in a hospital or pharmacy, right? It might be difficult to determine the cause of lost baggage for an airline, but it's usually easy to count the number of lost baggages and compare it to the total of right, the baggages that we served, or in a sample, or in even the whole number of baggages that we transported. So in that case, a percentage of defects, right, or P charts might be much more useful, much easier to manage, and in order to control quality of our service or manufacturing process.